Today we're going to talk about the periodic table. The periodic table that we have to the right is basically an arrangement of columns, and it's all the elements that are in columns are based on properties, and those that are in rows going across are identified with how many energy levels, orbitals, or shells. Henry Moseley is the current creator of this periodic table, and he arranged it by increasing atomic number. But prior to that, there was a guy by the name of Mendeleev, and he arranged it by its mass size. And it actually worked for the amount of elements that they discovered at that time. But later, when Henry Moseley arranged it, he realized it just didn't match up, and it's actually better to arrange them by increasing atomic number, and it makes it a little bit easier for us to identify. All right, on the next slide, let's talk a little more in depth about those rows and those columns. So first of all, when we look at these rows that we have here, they have a definite specific name, and they are called, the proper name is periods, which I'm circling right here. So those rows go across, and I'm going to draw a line through one right here, and as you go across those periods, the row itself, elements that are in that particular row have a certain amount of rings around the nucleus. Then we have, of course, our columns, and columns are called groups. And so when I look at the groups up here, let me circle the name groups. Okay, so groups are your columns. They go up and down right here, and they are arranged by properties. So we have rows called periods going across, and families and groups that go up and down in your columns. All right, so on a period, we basically have 7 periods that are identified on the periodic table. And basically all elements that are in that same row, as I said earlier, they have the same number of energy levels, shells, or orbitals. If you'll get your periodic table out at this time that I had provided for you, to the left side we're actually going to write and identify on the periodic table and number it from 1 to 7. So in the red, that's period 1. In the orange, that's period 2. The yellow here is period 3. The green is period 4. The light blue is period 5. The dark blue is period 6. And the fuchsia down here is period 7. So that means that if I have an element and it's over here in this particular zone, that means after I draw the nucleus, I'm going to draw 5 rings around it. So please remember on your periodic table that I provided for you, write 1 through 7 to the to the left-hand side and identify it from 1 to 7. Okay? Now, we also have groups. There are 18 groups, and they're arranged by their properties, valence electrons, and later we're going to see in Chapter 6 oxidation numbers. So up here, you have on your periodic table, there are A's above it. You have like a 1A, you have a 2A, right above it. So if you'll do me a favor, and all the numbers that are associated with A, circle them, and that will help you identify what group they're in. We have A's. This group in this region are called B's. We're actually not going to worry too much about these. These are called transitional metals. We will only know them by the group themselves, but overall we're going to focus in on the A's. This one is 3A all the way through the last one up here, which is 8A. It also has an 18 above it, and that's fine. Okay, that's fine, as I will accept either 8 or 18. Okay, on the next one, let's talk about those valence electrons. Valence electrons are basically the electrons in the very last shell. So in referring back to our previous slide looking at the rows, those electrons exist in that last shell. Okay, there is a code, and again, it's the number associated, as we circled earlier, with the letter A. And they are electrons in the last shell. Okay, and just to recap, we have up here, just to recap our Roman numerals, because some periodic tables have a Roman numeral in front of A, like Roman numeral 1A, Roman numeral 2A, all the way down to Roman numeral 8A. So the purpose of this slide is just to recap what those numbers state. Okay, so again, on the periodic table, you probably had a 2A up here at the top all the way to 18 over here. So when I count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then boron, this group right here would be 13 all the way to 18 on here. Now we're going to transition into Bohr's model. This is the scientist who had identified the nucleus, and then he identified your rings, what row the element it is in, around it to identify it. Okay, so it focuses on the electrons, and we're going to actually place those electrons in energy levels. For us, we're actually going to focus on the very last shell where those valence electrons occur. Niels Bohr is the guy who did develop this model. So the processes here, I'm going to go through these with Niels Bohr's model. Basically, you have to count and identify the number of circles that are around the nucleus, and that's what period that element exists in. Okay, so if an element is in the third row, you're going to draw 3 rings. If an element is in the 5th row, you're going to draw 5 rings. So you go to the very last circle right here. You're going to go to the very last circle, and you're actually going to identify the valence electrons, the number associated with the letter A. Okay, so we're going to practice this. Okay, so up here, we're going to start with oxygen. Okay, and I'm going to help you draw this one. So what I'm going to have over here, I'm going to first of all draw my nucleus and color it in. Okay, there's my nucleus. So I'll pull out my periodic table, and I find out that oxygen is actually in the 2nd row. Now if it's in the 2nd row, I'm actually going to draw 2 rings. So I'm going to do 1 ring for the 1st row and 2 rings for the 2nd row. Then I go up and I notice that oxygen is in group 16A. 16A, okay? But on there, we're going to note that there are 6 electrons in the last shell. Okay, so now I'm going to draw 6 dots around in the last shell. 1, 2, 3, 4, 5, and lastly 6. Okay, so those identify our valence electrons. So if it is 13A, they're 3. So it goes the code 1 through 8. 8 is the maximum number. Okay, now let's practice. Neon. I'm going to help you one more time with this one. So let me draw the nucleus. Okay, neon is in the 2nd row. So I'm going to draw how many circles? Think about that one. Count your rows. 2. So I'm actually going to draw 2 circles. There's 1 and 2. Now neon is in group 18 or 8A. 8A. So therefore I'm going to draw 8 circles or 8 dots to identify those electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? Now, at your seats, I will walk around, but I want you to try boron and helium by yourself. If you have any questions, please raise your hand, and I'll be more than happy to help you. Also, after this, we will be practicing more on those Bohr's model. Thank you. Bye.